Lesson 12.3 is on surface area of pyramids and cones. The pyramids that we're going to be working with are regular pyramids, and that would mean that they have a base that is a regular polygon. So please write that. The altitude goes through the center of the base and makes a right angle with the base as well. And the altitude is the height, and the height of each lateral face is the slant height. So that's a new term. The slant height, when it's represented in the formulae, will be with like a cursive L for the slant height. So whenever you see that cursive L, that's talking about the slant height. Okay. So we'll come back to this in a little bit, but if you want to go ahead and draw, this will be example 1. And we can label a little bit already. That 7 that's going down that face there would be the slant height. So that's the L. And then the altitude, I don't really need it, but if I did, it would drop straight down. This is on the inside of the picture. And then make a right angle there with the base. So that would be the height. So the actual height goes to the center, makes a right angle with the base. The slant height is on the exterior, like that. All right, and like I said, we'll come back to this in just a moment, but if you want to go ahead and have it drawn, that's fine. Just leave yourself some space because we're going to work it out in just a moment. Before we do that, though, allow me to share with you the 2 formulae for area here. Pyramid formulas. The lateral area doesn't include the base, and it's a half times the perimeter, and then that cursive L is again the slant height. And then surface area is very similar, except for we add the area of the base. So just like prisms, with pyramids, the base could vary. It could be a triangle, could be a square, could be a nonagon, could be a dodecagon. We can figure it out for anything. So whatever it is, we'll have to remember how to figure out its area and attach it at the end. So I'm going to go back to this one. So we're going to, example 1, we're going to find both things. So our lateral is, again, we just said, looking back, a half perimeter times slant height. So it's a half perimeter slant height. And the key is here, it's a regular pyramid. The directions will all be like that. So reminder, if it's regular, it's equilateral. So all of those sides have to be the same. So if there are 4 sides at a measure of 6 each, we could get the perimeter by just multiplying 4 times 6. So our lateral area will be a half. Perimeter 4 times 6 would be 24. Times the slant height, which we've already identified was our 7 feet. And at that point, we're ready to type it in. So key in that expression. And you should get exactly 84. And again, it's area, so feet squared would be appropriate. And then to get the surface area, it's the half perimeter times slant height plus the area of the base. So this part we already have exact, so I'm just going to write that down. We already knew half PL was 84. Plus, to get the area of the base, I'm thinking, well, it's a square. It's 6 by 6, which would be 36. 6 by 6, 6 times 6, 36. Add those together. So 84 plus 36, and we'll get exactly 120. And like we talked about in the last lesson, for pyramids or any other object, the surface area will always be larger than the lateral area because it is including the base, whereas the lateral area does not. So those would be your 2 answers, 84 feet squared, 120 feet squared. Next one, stepping up the difficulty slightly. Like we said at the beginning, pyramids can have any polygon imaginable for their base. So we're not going to get too complicated, but it doesn't have to just be triangles or squares. It can be, in this case, if you count sides, there are 1, 2, 3, 4, 5. So we would call this a pentagonal pyramid. So I'm going to rewrite the formula. We've got lateral area is a half perimeter times slant height. And then when we get to its surface area, it will be that same thing, a half perimeter slant height plus area of the base. So what I notice on this one, to begin with, we don't know the slant height yet. The slant height would be connecting that down to that, and we just don't know it. There's no value there. So I'm going to put an L there for now. So we're going to have to figure that out before we can finish this up. The perimeter we could go ahead and get. So I'm going to start plugging in what I know. The lateral area would be a half. And to get the perimeter, there are 5 sides at a measure of 12 each. 5 times 12 would be 60. Times, we're going to have to do some work to figure out that slant height. Okay? So my thought would be this. I know that's 10. I want this. I'm also going to need this down at the bottom eventually anyway. And what I'm going to do, and I want you to do as well, is redraw that pentagon. So we're just kind of looking at our base. And that blue line that I just drew in there would be the same as this blue segment that I just drew, which would be our apothem. So we need that for 2 reasons. 1, to find the area of a regular pentagon, we need the apothem. And 2, we can use that to then figure out our slant height. Okay? So something we've done a few times already, we're going to draw that in. We're going to figure out what that angle is. So to figure out our angle, we're going to take 360 divided by, there are 5 sides, which gives me 72 degrees. But we don't want this entire central angle. We just want the part in blue, so we divide that by 2 and get 36. And then next thought, we knew the whole side right here was 12, so just this part of it would be 6. And then I'm thinking the 6 would be opposite of the angle. The apothem would be adjacent the angle, so that tells me tangent would work. So ka toa, TOA is what we've got going on. So tangent of our 36 degrees would equal 6 over A, multiply by A, cancel that out, divide that over, so A is 6 over tangent 36. All right, and that was the missing piece that I needed. So that's what this is right here. 6 over tangent 36. To get my slant height, if I know these 2 sides, I could use Pythagorean Theorem. So typically what I have said is to only round once, but I'm going to let us not do that. So I'm going to go ahead and type that in and get it as a decimal. Because otherwise, that's going to be a bit more than I would expect you to type in at once. So I'm typing in 6 divided by tangent 36. And I'm going to go ahead and replace that with what I just came up with. And since this isn't our final answer yet, let's go at least to the nearest hundredth would be good. So I would say 8.26 is that measure. So to get the slant height, Pythagorean theorem would work. So I could do 8.26 squared plus the other side, 10 squared, equals our slant height squared. So 8.26 squared gives me, again, let's go at least to the hundredth, 68.23, plus 10 squared, is 100. Add those together, get 168.23. And then to get rid of that, root both sides. And that gives me 168.23, about 12.97. And then that can go right there. So evaluating it, a half times 60 times our 12.97. I'm getting approximately, double checking I typed it in right, looks good, 389.1. On my screen I got that exactly, but I know I rounded throughout this, so I'm still going to say approximately meters squared. So our surface area, give myself a little bit more room here. already know half PLs are 389.1. Plus area of the base, since it's a pentagon, we can do that half times the apothem times the perimeter. And we've already got everything. Our apothem was that 6 over tangent 36, so half times 6 over tangent 36. And then our perimeter, we already figured out here, was 60. So that would go at the end. And then you can key it all at once. I would do a little bit mentally first, like in this case, a half times 6 gives me 3. 3 times 60 could become 180. So I would avoid typing it all at once, and I'm just doing 389.1 plus 180 divided by tangent 36. And I'm getting approximately 636.8. And that seems valid to me. Like usual, the surface area must be larger than the lateral area, which it is in this case. Well, that's a relatively large base because all the sides are 12, and this whole thing's only 12 or 10 tall, so it is definitely wider than it is tall. So, seems good. So if you need to, feel free to watch this part again. These are very involved problems that you are pulling from things that we did in Chapter 8 with the trig and the Pythagorean Theorem, and things that we did in Chapter 11 with the half apothem perimeter, and then you're putting it all in. So take your time. There are quite a few steps, but that's what these will be. Cones will function like a pyramid in regards to height and slant height. So to find lateral area of a cone, our formula is pi r L. Pi times the radius times the slant height. And then to find the surface area, it's that pi times radius times slant height plus the base, which is just a circle, so pi r squared. So example 3, we're going to find both of them for this one here. So the slant height goes on the exterior like that, so we don't know that right now, so I'm going to put that L there. But I do know the radius is 5, and that's 8. And just like the prior problem, we can do Pythagorean Theorem to find what we need here. So we would do 5 squared plus 8 squared equals L squared. Gives me 25 plus 64 is L squared, which would give me 89 is L squared. Root 89, I'm just going to leave it like that for now, because that's not going to give me an exact value, so I'm just going to leave it as root 89 for the time being. So in our lateral area, it will be pi times the 5 would be the radius, times the slant height, which we said was root 89. So I'm going to wait until the end to type it in, be as accurate as I can. So if I type in pi times 5 times root 89, I am getting 148.2. And that would be centimeters squared. So make sure when you're typing these in that you're getting what I get. And then surface area, kind of repeat it again. I've got pi RL, so pi times 5 times root 89. Rather than just copying this down, I'm going to type it again just to give myself a little bit more accuracy, since that's a little bit rounded. And then pi times 5 squared. And upon typing that in, I'm getting that my surface area is about 226.7 centimeters squared. And those seem like reasonable answers to me. Right, and that is how you find surface area and lateral area for both pyramids and cones. As we kind of modeled here, the cones aren't going to be as involved, but pay attention to if you have the diameter, you need to have it before you plug it in for the radius. If you're missing the slant height, you're often going to do Pythagorean Theorem. Other things that might come up, if I give you an angle instead of one of the sides, then you might have to use sine, cosine, or tangent. That will come up some on the assignment. So recognize things that we have learned in the past and utilize them. Problems like this are going to be worth quite a bit. And this will be worth quite a bit of points on the test as well when we get to that in a couple weeks. They're pretty involved, so again, take your time on your steps. Make sure that you are showing all of this work, because there is no way to get those answers without going through this process. So especially on these, there should be quite a bit of work. Easier ones like this, not as much. So for some of you, that might just be a key in or mental thing, and that's fine. But if it's involved like this, make sure all those steps are written out, please. If you need to, feel free to rewatch this, go back to any specific examples, and then homework will be due next time.